Functions and graphs. This is the section, the topics. Functions provide the mathematical framework to model the world around us. Graph offers a visual language to understand and interpret these models. So that's the reason we're covering these two topics. Let me go over the big picture. What happens is, in the world there are problems, and as a college algebra student or as a math student, we try to bring those problems and convert that problem into mathematical problem. We have to, most of the time, we have to use some kind of modeling so that we can convert the problem, real problem, into math problem. And for that, functions are very, very useful. That's the reason we're talking about the function. And graphs help us to understand more about the function. So these are the reasons for this topic. These are the topics we're going to discuss. We need to find out whether the given relation is a function or not. We are going to talk about how to find the values of the function using the formula or the graph. Ultimately, our goal is to graph the function if it's possible, which we are going to start in this section. And if you have given a graph, either that is the graph of a function or not, there is a way to find it out. We're going to discuss about that. Eventually, our job is to find the domain and range of the function, and then eventually, solving the application problem. So what is a function? A function is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to exactly one member of the range. So let's say there are two parties. For example, let's say you have two parties here. Party A, and there is a party B. Let's say party A, this set, these are the members. Let's say names, name A, B, C, and these are their A's. For example, let's say 20, 15, 16. So A, the A's of A is 20, A's of B is 15, A's of C is 16, something like that. So this is a relation. This is the correspondent between two sets A and B. That's a function. Keep in mind, to be a function, every single element in first set, which is also called domain, whatever comes first, that's the domain. Every single element here must have a unique element here in set B, which is also called range. Okay, unique means it cannot be repeated here. Like for A, there must be only one output. This is called input, this is called output. So there are different names for this A: domain, input, range, output. Okay, it is important to note that not every correspondent between two sets is a function. So if you go back to the very same example here, I can make a similar type of example here. Input, I'm just naming them as a and B. Let's say A goes to 20 and A also goes to 30. So there is a party A or person A whose age is 20 and 30. That's the meaning of this picture. But that's not possible. No one has, age which is two different ages at the same time. That's not possible. So this is not a function. 15 and then C was 16. So look, A is going towards 20 and 30 for one single element in the domain. There are two different outputs, so that's not the function. It is important to note that not every correspondent between two sets is a function. So as you can see here, this is an example of correspondent between A and B, but it's not a function because it's not exactly one member of the range. More examples. Negative 6 goes to 36, positive 6 goes to 36. There is no problem because two parties could have the same output. This correspondent is a function because each member of the domain corresponds to exactly one member of the range. Negative 3 gives you 9, positive 3 gives you 9. No problem. Repeating here on the range side is not a problem. Okay? But for one single input from the domain side gives you two output. If you have two different arrows coming from the same input, that would be a problem. Let's go to next. Let's go to next example. For example, instead of this, let's say you had negative 6 and there are two arrows going like 5 and negative 5, then that's not the function because for same input negative 6 there are two outputs. So the first set it's called input, the second set it's called output. Okay, this is the function but this is not. I'm giving you a different example here. So let's look at some example from the problem. Determine whether the correspondent is a function. These are the sets of the domain and these are the sets of the range. 16 is giving you 15, 18 is giving you 8, 5 is also giving you 15. This 15 is for both of them, that is okay. Two arrows can go to the same elements in the range. So this is a function. What about the next example? Here, these are the sets of the domain and these are the sets of the range. As you can see here, y, from the y, there are two arrows coming, are going towards two different elements. So y as an input gives you two output, v and capital V and capital Y. That is not a function. It must have just only one arrows. So it's not a function. Sometimes you might have a problem like this. It's the list of the order pair. You just try to see if the input is repeated like 11, 22, 43, 11. Look, 11 gives you 2 and 11 gives you 6. So for the same input there are two output. So this is not the function. But if you are trying to find the domain and range of this kind of collection, domain means just the collection of the first elements in the order pair, like 11, 22, 43, 46 without repeating 11. So 11, 22, 43, 46. You don't have to repeat the 11. So that's the domain of this list. So what is the domain? Domain means the x coordinate. What is the range? Range means the y coordinate. So after function, relation. A relation is also a correspondent between the first set called the domain and then second set called the range, such that each member of the domain correspondent to at least one member of the range. At least one member of the range. So keep in mind the difference between these two definitions. Here it's exactly one. For the to be function it's supposed to be exactly one. But to be a relation there is not such type of requirement needed. It's just at least one. So if you see correspondent between two parties and for every single input there is at least one output, then that's a range. This problem is not a function because 11 is repeated, but this is the relation because 11 has a 2, 22 also has a negative 8, 11 has also 6. So this is the relation, but it's not a function. What about the range? Range means the y coordinate, the collection of all the y coordinate. In this case it's a 2, negative 8, 2 is repeated, no problem with that. 2, negative 8. I'm just collecting the y coordinate without repeating. So that's the range. Is this relation a function? No, this is a relation because it's a correspondent. Whenever you see correspondent between two parties or two or the list of order period, that's always relation. But because 11 has two output, so it's not a function. Okay, I'm not going to do the same problem here. So we know difference between the relation and function. Next, we use a very special type of notation for the function. We denote the function as a, like for example here, it's f of x. F of x means it's a function of x. So this is just a notation, it's just a name. What is this? It's a function of x. What is x? X is a variable. The input, this x, this is the input. And the value of the function, everything, which we denote by y as well, that's the output. Okay, the input, which are the members of the domain, are the value of x, which we are going to substitute in the given formula. In this case, it's not given any formula here in this example, but I'm going to give you the output is the y value. That's the member of the range. Okay, so whenever we try to plot the graph of the function, we are basically collecting all the x coordinate and y coordinate. X, that's coming from the domain. Y is actually the value of the function. So you might see y or f of x, but both of them, they mean the same thing. So if you want to plot the graph of a function, make a table of collection of x and y, and then just plot those points, and that gives you the graph of the function. For example, let's say we are trying to plot the graph of this f of x equal x squared. So what do? We make a table, x and y. Keep in mind, y means actually this f of x. And what is that? That can be calculated by using the formula x squared. So y is x squared. So let's assume that x is 0. Then what is the y? This is the formula we're going to use to calculate the y. Y is square of the 0, which is again 0. Let's say x is -1. Then y is square of the -1, which is +1. Let's say x is +1. Then square of the +1 is 1. Let's say y is -2. Then square of the -2 is +4. You can use a calculator for that. And we just collect this type of the points, and we try to plot them. Okay, so if I put x equal to 2 in this formula, 2 square is 4. So what is the graph? What is the graph? Graph is just plotting these points. So you have to draw the Cartesian coordinate system, x axis, y axis. Plot these points. 0, 0 is here, -1, +1 is here, +1, +1 is here, -2, +4 is here, -2, sorry, +2, +4 is here. So if you keep going like this, you are going to get infinitely many points, and if you join them, and that's how you get the graph. That's how we plot the graph of a function. Sometime they give you a function or they give you a graph, and we need to find out either that's the graph of a function or not. For that, we can use this test that's called vertical line test. If it is possible for a vertical line to cross a graph more than once, then graph is not a graph of a function. So if you have a given graph and just scan the graph from left to right, if you see a place where a vertical line can cross the graph more than once, then that's not the graph of the function. I'm going to give you an example here. Okay. determine if the graph is a function. Let's say this is the graph. Is this a graph of a function? When we scan from left to right, no matter how many vertical line you draw, no vertical line crosses this graph more than once. So yes, this is the graph of the function. What about this one? No matter, this is the graph. You can see here there are so many vertical lines. Even this single line, it's giving you, it's passing through the two points. So this is not the graph of the function. The vertical line is intersecting more than once, giving you the more than one point on the graph. So this is not the graph of the function. Here, if I draw a vertical line somewhere here, even there are so many lines, infinite lines. As you can see here, they are intersecting the graph more than once. The case supposed to be no vertical line supposed to intersect more than once. Here we have so many vertical lines crossing the graph more than once. So this is not the function. Okay. Before go to the next problem, here, this is the function we have given. Now our job is to find the value of the function when x is 0. So meaning you use this formula, you put x equal to 0 in the formula. What do you find? If x is 0, so I need extra blank page. Okay. So in this problem, as you can see here, g of 0 means 3 times 0 square minus 4 times 0 plus 2. This is 0. This is 0 because 3 times 0 is 0, 4 times 0 is 0. The value is 2. So the value of the function g at 0 is 2. So in that way, we can find out the value of the function at any point. Okay. Sometimes they give you the graph and they will ask you to find the value of the function at -1. So you go on the x-axis, at -1 is here, and you find the point on the graph at -1, which is the y value, which is 2. So the value of the function at -1 is 2 from the graph. Okay. Okay. So vertical line test is very, very helpful for finding the graph, either it's a function or not. Next, this is very useful, finding the domain of the function. Domain means the x values. When a function f whose inputs and output are real number is given by a formula, the domain is understood to be set of all inputs for which the expression is defined as a real number. When an input result is an expression that is not defined as a real number, we say that function values does not exist and the number being substituted is not in the domain of the function. Basically what it means is, if you have a function and if it's given in some kind of, let's say for example here, f of x equal x square, basically domain means what x value I can pick so that I can calculate the value of this function. Is there any restriction for me to pick the value of x from the real number? Real number means from -infinity to +infinity. Am I allowed to pick the value of x from anything from -infinity to +infinity? If the answer is yes, the domain is all real number. If I do have any restriction, then those restriction is not supposed to be part of the domain. So for this particular example, there is no restriction. I can pick x positive value, I can pick x negative value, I can pick x 0. So no matter what x I pick, I can calculate using this formula. So the domain for this function is all real number. So there are two restriction you have to be careful with whenever you try to find the domain. If your function comes as a rational function, meaning something on the denominator, you cannot have 0 on the denominator because division by 0 is undefined. So in that case, you have to make sure that you cannot pick x as a 0. Okay, and another restriction is a radical sign. Whenever you see, like for example, this root, square root, the thing inside the square root is supposed to be non-negative. Other than these two restrictions, most of the time the domain of the function would be all real number. We are going to talk about this thing again in future, but for now just keep in mind, domain of a function we are talking here in this course, most of the time we start with the all real number unless the function appear as a fraction or the radical sign. If there is a fraction, then we cannot take the value of x which makes the denominator 0, the bottom part. Or if there is a radical sign, especially the square root, we cannot take the value of x which makes the things inside the square root negative. Those are the two restrictions you always have to keep in mind. Okay, so if you try to visualize the domain and range, domain means this is the x values. So if you have a graph, for example, let's say this is the graph you have given. Let's say this is the graph. So the domain means what x value you have on this graph when you go from left to right. That's the domain. Domain means all the x values. Range means all the y value on this graph. Okay, graph is what? What is a graph? It's a collection of points. So a point has an x coordinate and y coordinate. All the possible x coordinate, that's the domain. All the possible y coordinate, that's the range. Okay, so let's look at some problem here from the homework. Find the domain of the function. Okay, this is the linear function, 2x plus 3. Do you see radical sign? No. Do you see fraction? No. Then just write down the domain as an all real number because we don't have any restriction. I can choose x as a positive number. I can choose x as a negative number. I can choose x as a 0. I don't have any restriction to pick the value of x. So domain is supposed to be all real number. Here, do you see the fraction? No. Do you see the radical sign? No. Then domain is supposed to be again all the real number. And this is how we write all the real number. Anything from negative infinity up to positive infinity. So in the interval notation, that's how we write all the real number. What about here? Do you see fraction? Yes, there is a fraction. Things on the top, things on the bottom. So think about the value of x which makes the bottom part 0. If I pick x equal to 8, 8 minus 8 becomes 0. So I am not allowed to pick x equal to 8. So 8 is not the part of the domain. So that's what I was talking here. If you have a fraction, then you have to keep in mind you cannot have the value of x which makes the fraction, the denominator, 0. So in this case, whenever you have a fraction, copy the bottom part. So in this case, it's a 8 minus x and make it equal to 0 and solve for x. So you can see that when x is 8, the bottom part would be 0. 0 on the denominator is undefined because division by 0 is not allowed. Okay, so In this case, we can say, hey, the domain is all real number except 8. So how do you write it in the interval notation? So initially this is supposed to be the domain, but you are not allowed to pick 8 from here. So what do? You start from negative infinity, you go up to 8, you use the parenthesis. Parenthesis means do not include 8, and then you pick anything from the right side of the 8. So you use the parenthesis 8 and you go up to positive infinity. These are the two intervals, but you are not allowed to pick 8. So how do you write it? You just have to use the union sign. So anything from the left side of the 8 and anything from the right side of the 8, they are allowed to be in the domain. So this is how you write the domain. How do you write it? Anything from left side of the 8, union anything from right side of the 8. So that's the domain of this function. Excellent. Okay, that's all for this section.